So essentially every reversible reaction has what's called an equilibrium constant. Okay, and we're going to get into that. So we've been talking about rate constants, that K in my rate equation. And we said at equilibrium, the rate of the forward reaction equals the rate of the reverse reaction. So I'm going to show that again now. Kf times, this was the forward reaction in the example above, equals Kr times NO2 squared. Okay, so if I'm going to try to get a ratio of these, Kf to Kr equals the concentration of NO2 squared over N2O4. Okay, and what this is called when I am getting a ratio of the rates is big K, which is the equilibrium constant. Okay, and each reaction that is reversible has an equilibrium constant. So when they're at equilibrium, it's actually a comparison of the concentrations. Okay, so equilibrium constant, every reversible reaction has one. Reaction has, and I'm just going to write K. Has a K. K does change with temperature though, so keep that in mind. K changes with temp because if it's higher temperature, you can cause more collisions to happen essentially. So K changes with temperature, just kind of keep that in mind. But how do I actually calculate K? What does big K or the equilibrium constant mean? So if I were to write a generic reaction, so I like doing AA plus BB makes CC plus DD. Oh, and by the way, the reversible reaction arrow is a half arrow to the right, half arrow to the left. Please don't do a double-headed arrow. That's not technically the same thing. That means something else. So just kind of keep that in mind. So if I'm going to write the equilibrium reaction based on the concentrations for this, remember it's a comparison of the forward and the reverse. So K is actually equal to the products, which are C to the power little c times D to the power little d over A to the power little a over B to the power little b. This is the generic form of K. We can actually calculate K if we have all of the concentrations. Okay, this is like one of the only times I will tell you this. There are no units on K. All right, these stand for molarity, right? But they're all going to cancel out, at least for the most part. So there's no units on K, the equilibrium constant. Okay. All those concentrations cancel out. So if I said, write the Kc expression for this equation, what you would do is you would write Kc, now C stands for concentration, and I'll talk about that in a minute, is products, remember? So CH4 times the K concentration of H2O over the reactants, CO, times the concentration of H2, and it should be to the power of any of their coefficients. So this is how you write the K equation for this specific reaction.